Welcome to the weekly challenge videos. If you like this kind of content, please like or subscribe. And if you'd like to see even more of these challenge questions, I have a lot more on my courses website, link in the description below. So a car is traveling at constant speed, v, and making a turn around a flat corner. Assuming the tires on the road have a coefficient of static friction μs, what is the smallest radius r that the car can make without slipping? So here we have a car, and it's going in a circle. So let's just, I'll give a top view of a car here. Wheels here. And he's making a turn with the radius r here, right? So if we look at the side view of the car, we want to look at a free body diagram. Okay, he's turning this way to the right. Now, what are the forces acting on the free body diagram? So we have gravity acting here. We also have a normal force, right? Normal force is due to the road pushing up on the wheels, right? Now, are those all the forces? Well, he has to be accelerating towards the center of the circle somehow, right? So what force is causing that is there must be a force that's directed towards the right. And that would be the frictional force. That's what keeps it here. We're talking about coefficient of static friction. It's the frictional force. Now it's static friction because the tire is not slipping relative to the road. Okay, it's doing this nice smooth motion, but that's static friction. And so that's it. Nothing else is touching the car, right? Gravity's pulling down on it from the earth, and then the road is pushing up on it, and then we have friction also due to the road. So if I look at the net force here, let's look at the x direction first. Net force is just the force of friction. That has to equal ma. All right, and it is in the horizontal direction. It's doing centripetal acceleration. So we do v squared over r. So that's the first equation that we get. Now in the y direction, the net force has to be, let's say upward is positive. So normal force minus mg is equal to ma. But the acceleration is 0 in the vertical direction because the car is not accelerating up or down. So here the normal force is equal to mg. Now if we're talking about the smallest radius r, we're talking about the largest that the force of friction can be, right? Because the smaller r is, the bigger the force of friction has to be. That's why making a tight turn, if you're in a car and you need to make a very, very, very tight turn, you have to go slower, or it requires more friction to make you make that turn. So in this case, we know that the force of friction, what's the maximum the friction can be is μs times the normal force. That's what the maximum static friction we can have is, right? So that will give us the smallest r. Now the normal force is from here equal to mg. So we can then we can plug that in. Μs mg is equal to mv squared over r. And here the masses cancel. I divide both sides by m. So that allows us to not know the mass, you see, because the mass wasn't given in the problem here. So we can multiply by r and then divide by μs and g. Move that to the other side. Okay.